going and measuring space. We're trying to develop mathematical models that explain what we see when we look into space.
Like a biologist classifying new species, Weeks is cataloging the shapes of three-dimensional space. Each is a model astronomers can use to test their observations. Among thousands in this library, one may someday be found to be the shape of our universe.
I've written the computer programs to increase what we know about the mathematical universe. So it's like this big world filled with these creatures. I mean, not physical creatures, but mathematical creatures. And we want to learn something about them. We want to learn how they're related to one another, what the patterns are. There are these beautiful interconnections, and we just don't understand all the details.
Curved spaces have properties that are similar to the Earth's surface. A person going in one direction will eventually return to the starting point. Although the Earth's surface is a finite area, someone can travel forever in any direction without ever reaching an edge. The same can be true of curved space.
It's going on its way. The central mystery is how you could travel off in one direction and come back from the opposite direction. In 2 dimensions, this is easy enough to understand. Think about the 2-dimensional universe, an ant's universe, as it were. If one of these creatures starts off in some direction, they'd imagine they just keep going forever. What else could possibly happen? That there are other possible shapes their universe could have. It could be a cylinder, like the trunk of a tree. Okay, so if an ant starts walking and what it perceives is a straight line around the trunk of this tree, it'll come back to its starting point. Yeah, pretty strange, huh? It's harder to visualize how 3-dimensional people in a 3-dimensional universe could head off into one direction, travel straight the whole time, and still come back to their starting point.
To help people imagine a ride in curved space, Weeks and his colleagues created a video that depicts a bizarre journey.
We're starting with a solid cube of space. We want to think of opposite walls of this cube as being glued to each other so that any creature moving out one wall will come back from the other wall. Similarly, going to the top and the bottom, the front and the back. So this hooks this cube up into a space which has only a finite volume, but it has no edges. You can travel wherever you want as long as you want. You'll never hit any edge, but there's still only a finite volume to this space.
From the spaceship's point of view, the tiny universe repeats itself endlessly with no perceivable edge or boundary, much like what the earthbound ant would see going around and around the tree. The cube is a simple case, but in all cases, curved space is connected to itself, which implies that if our universe is curved, it has no edges.
The central idea here, the exciting idea is that space could connect up with itself. Faces with the same color are connected to one another so that a spaceship traveling out one face would come back in another face with the same color. So it's like tab A goes in slot B. That's sort of instructions for assembling your space. Okay, let me turn off SnapKey here.
Through computer games, Weeks shares his knowledge of curved space with his son.
The reason for writing a game is to give kids something where they could subliminally absorb what this space is like. You want to go first?
I'm white.
Yeah. My son Adam, even when he was a preschooler, he'd look at some of these games like the tourist chess where you go off one side and you come back from the other side, and this was absolutely no problem for him. When you're 3 or 4 years old, everything in the world is a surprise. Everything's new and wonderful. And why shouldn't it behave like that?
Does that mean that I've won because all you have is your king?
I think that means you won. I'm also in check here. Yeah, I will concede. Good job. Oh, cool.
That's glass, right?
Yeah, it's something that's not normal grass. I really like working as a consultant.
Piece of wood.
I can do my work in the morning, and when Adam gets home, we have a chance to have a few hours together each day.
Oh, take that. Wood. I'll go in.
That's an important thing for me. It's nice being able to do it. I think no matter what he ends up doing for a living or what his interests are in life, seeing some of these beautiful aspects of nature, the real nature outside, and then also the beautiful aspects of mathematical nature can only make life richer. There are two domains of exploration here. There's the real universe, which we explore physically with telescopes. And then there's the mathematical universe that we explore with our minds, with using the computer as a tool, with pictures. Real nature is beautiful. If you go out and you look at a flower, or you look off into space, it's a miracle that we have this physical universe to explore. I think it's no less a miracle that we also have this mathematical universe to explore. It's full of beautiful, intricate patterns lying there, waiting to be discovered.
For centuries, we have explored two universes and discovered that one leads us back to the other. We have developed mathematics to explore the Earth and to map and navigate its vast surface. Exploring mathematics, we have discovered models that enable us to envision the universe. Our journey of exploration may be a voyage like Magellan's that never seems to end, but may someday bring us back home where we began.